So the question that we have, a very simple question. Are you ready, Kevin?
Oh God.
Does fruit float?
Yes. A watermelon floats, so yes.
A watermelon floats. How do you know a watermelon floats? Okay, so we have some prior knowledge. We got some background knowledge, right? And at the pool, we do a watermelon race. So you throw the watermelon in the pool, and it floats. You push it. Okay, so we might have watermelons that float. Okay, do all watermelons float?
I don't know.
You don't know, so we'll have to test that.
I'm pretty sure a pear floats and an apple doesn't.
Okay.
Or it's the other way around. I don't.
Now, this is something that, again, based on culture and what we do at events. If you've ever been like at Halloween or October and so forth, we bob for apples.
Yeah.
Do you know
You
what?
don't bob for pears.
Okay, but what does bobbing for apples mean? You shove your head in the water and you try to grab an apple, which is floating on the water. So does an apple float?
Yeah. it's that apple.
Maybe all apples float. But do we know if a
Different
red
colored
delicious apple floats compared to a granny floats? All right, so
Let's
let's test
test
this
it
out.
out.
All right, hang on a second. Okay, so.
I'm not making this fun. Get out.
Okay, how are we going to
Yeah.
test this, Kevin?
Well, certainly Mommy doesn't think we should test it by putting it in the water.
Okay, well here,
Clouds of action.
let me see the apple for a second. Okay, so we're just going to put this in the water, right? So I'm gonna put this in the water. Is that how we're going to test it?
No.
No? Okay, so I'm going to drop it. So I'm going to drop it in the water?
Yeah.
No, how do I want to? Okay, so when you're doing science, when you're doing an
Hot
experiment,
out
you have to actually define what drop it in the water means. So how am I going to put it in the water? Place it in the water. So I'm going to place it in the water
Yeah.
and then let go? Or am I going to place it above the water and let go? You think above the water. Okay, so let's
Right
decide that
here.
we're going to take the apple and we're going to place it in the water. Ooh, and we've got something that floats. All right?
Pear.
Hang on a second. Does this mean that all red apples float?
No.
So we would have to do another test. So let's do another test real quick. We're going to do the same procedure. Place it in the water. Hey, we got two. Well, that might mean that red apples float. Well, if we're going to compare red apples, we might as well take a second and compare our other apples. Why are things floating and sinking?
Because they're composed of water
Okay,
and air.
and air.
So
So anything composed of water and air is just going to float? Why are things floating? We drown?
We're composed of water and air.
Okay.
We just fall.
So how is it that things are floating and sinking? Do you know the science
the buoyancy.
reason? Buoyancy's in there, so suddenly we have a word that we're using, buoyancy, and then what else? Huh? Buoyancy?
It means it like bobs up and down.
That does mean it bobs up and down. It ends up being how much? 8th grade, 4th grade, all right? We're going to be using a big term. We're going to use the word density, okay? How heavy something is compared to its size, right? You asked the question, does a pear sink or float? So let's just...
Pretty short thing.
Ooh.
I was partially right.
Okay, now, you're partially right. Are you
Kind of
partially
like
right, or are you right?
It kind of stays under the water, but it doesn't necessarily stay on the bottom. Let's
Okay,
test with this one.
so suddenly, hang on a second, wait. Suddenly we have to have a definition of what sink means, right?
Sinks
Because
all the way to the
it
bottom.
sinks all the way to the
Stay
bottom, so if it's
Stay there.
midway, if it's an inch above the bottom, is it floating or sinking? Is it? I mean, so suddenly we now have to have an operational definition of what we mean when we say sink or float. No, it's not flinking. Clearly.
It's linking.
Yes, okay, so we're going to come up with our own scientific definition. All right, try the other pair. Let's see if there's a difference. I would say that that's clear on the bottom. I think that's sank.
Oh.
Okay, but what did you just do? You changed the experiment. Is that the same conditions that this pair is in? No. So, is that volume of water different than this, and did you just do a totally different experiment by doing it in a different container?
I guess.
So take it out, and let's see if it actually will sink in this one over here. Oh, hang on.
What? This
Okay.
pear is a floater.
So suddenly we can't say all pears sink, right? Because some pears seem to be
Floating.
floating, and some. So there's no definitive answer of these pears.
Yep, and this one just sinks to the bottom.
Strawberries are floating. How about grapes? Sink or float?
Sink, float.
Float. Because we saw strawberries, so we're thinking same size. Oh,
I was right!
different density. So we
I
have
was right.
an object here. Now, does that mean all grapes sink? Well, maybe not. We'd have to try red grapes. We'd have to try all green grapes. We'd have to test it out. But we're able to say, for the most part, that these are objects that do.
This is the inside
Now,
of the
these
grape,
have a
but this
different
is the
aspect to
inside.
them. What's that now? They have a shell. What do we call it? In Brazilianese, they have a shell, right? But you know, in English language, as you eat our apple, what do they have around them? They have a peel. Now, so the question is, does the peel affect this? You think the peel affects it? Okay, so here it's floating.
1
Okay,
second.
so that means maybe we have to actually take a look at this. All right. So, with a simple question, we've been able to go in like 10 different directions. We talked about peels. We talked about what the definition of sinking is and floating is. We talked about vocabulary like buoyancy and density. All right. So with a simple question in the world of science, we're able to ask a whole bunch of questions. Ready? Oh!
I don't like your behavior, Mom.
I don't think we proved anything. The amount of water now ends up
It's
being part of
gone.
the equation because we do know that watermelons float, but in this case, the amount of water displaced, the size of the watermelon affects the overall experiment.